Sup, junkies? Remember, keep your brain cells and your teeth. Smoke math, not meth. The more math you smoke, the better at it you get. It's just simple as that. So today, I'm going to give you a mathematical model, and you are going to tell me what you think I'm modeling in the comments. The primary lesson today is linear functions versus linear functions. So first, let's go over briefly what a linear function is. Well, as the word suggests, it's a chucking line. That's right. You got some graph, xy, and it's a line. For every input of x, there's output of y. Over here, that shit, giving you an xy. So you have a function that maps r1 to r2. What's all this shit mean? Well, it means roughly this. This is the x-axis. It's one-dimensional left to right. This is the y-axis. It's one-dimensional up or down. Because it's one-dimensional up or down, it's r1. Because it's one-dimensional left to right, it's r1. When you multiply those two together, r to the 1 times r to the 1, that equals r to the 1 plus 1 because of exponential rules. And you can combine that to give you r2. That's really all that shit means. It took me a long chucking time to figure that shit out. Word the chuck up. All lines have, well, the same effing formula. Y equals mx plus b. M is called the slope. It's basically how steep this shit is. If you look at this right triangle right here, this has some sort of slope to it, and the slope is defined by m. It's defined as the rise over the run. So I'm going to rise this distance y, I'm going to run this distance x, I'm going to put that value here, and that's going to give me m. Remember, when you see all this variable shit, it's just a number. y1 over x1 looks really complicated, but it really just means m, which is simpler, but this is really just a number like 2. But let's get into some shit that's what we all look for in this crap. We're always going to set y equals 0, and we're always going to set x equals 0. We're interested in where it crosses the y-axis, where it crosses the x-axis. If I say y equals 0, I'm going to solve for x, subtract b from both sides, divide by m. It crosses the x-axis, its root, at negative b over m. Remember, that's just a number, like 1/2, negative 1/2. Positive 1/2. The negative sign really means shit. The negative number, then you'd be adding it to both sides, then you have the negative positive, and it'd be a negative. Vice versa, whatever. If you said x equals 0, you get y equals 0x plus b, and of course x, you get y equals b, aka the y-intercept. So that's the shit we're interested in a linear function. Now let's talk about a linear function, all right? It's a very subtle difference, but I'm going to do it via a model, an application to biology. And I'm going to, as the modeler, I can choose the variables. I can pretty much create it. The model could be a complete lie. I could test it in nature. It could work and it'd still be a lie. Always be skeptical of models. Climate models, pandemic models, they're only as good as the modeler and the input that's put into it. And I'm going to demonstrate that. So with my linear function, okay, I am going to label the x and the y axis. But I'm going to give it my own labels. I'm going to give the horizontal axis sigma, and I'm going to give the vertical axis beta. All right. So I'm also not interested in the entire sigma axis from negative infinity to infinity. If you think about it, when functions are nice, infinity, negative infinity, this shit don't make sense anyway. Because what's it mean to be infinite? Nobody knows. So the universe had a beginning. So negative time is not infinite. Time had a beginning. We can go into the future, but how far? Who knows? Most people think it's going to be the big chill. People a lot smarter than me. The universe is going to freeze. Everything's going to die. Black holes are going to evaporate, yada, yada, yada. In time, will it ever end? Who knows? Who cares? We're not going to be here for that shit anyway. But in this case, in most things, we're not interested in the entire axis. In my model, we're not even interested in negative sigma numbers at all. Don't even care. In fact, so I'm going to label the domain, okay, the domain in my linear function, okay, because in a linear function, you put something in, like a number, you get something out. In my linear function, you're going to stick something in, and it's going to spit something out, all right? So in the domain, since we're not interested in negative numbers, we're only interested in numbers greater than 0. So I'm going to name my domain omega, okay? And I'm going to put a lower limit on domain of omega as 0, and I'm going to put an upper limit on domain as p, on omega as p. So I don't know what this number is. It can go as far as it wants to in that direction, but you cannot have negative. Inside omega, we have all of our little sigmas, right? The ones that are valid. Okay? So I'm going to pull a sigma out, just like that, and I'm going to name my function pi, because I can. So the sigma is going to come out of omega, it's going to go into the pi, and when the sigma gets into pi, it's going to do its fuction thing, and then it's going to spit out the beta. And since this is a linear function, okay, it has to have the form beta equals pi of sigma equals m sigma plus v. Now again, I can name these two constants anything I want. This can be a 1, a 2, 1,000. This can be a 1, a 2, or anything, but it cannot be a negative number. I just named these that to help with my linear function. So you can use this to deduce what it is that I'm modeling. Let's take a look at some numbers here. Let's draw us a little chart. We're interested in omega from 0 to p, and then we're going to have some number m, some number v, and zeros, and it's going to pi of sigma equals beta. So remember, the goal here is for you to figure out what I'm modeling in biology and if the model is accurate, all right, if it's an accurate model. So let's just do some random things here. Let's just go 0, 1, and then let's do an m as constant 1, a v as constant 1, and let's plug it into the formula and see what happens. So we have 0 equals 0 plus 1 equals 1. So we're saying here that at sigma equals 0, m equals 0, or m equals 1, that we're going to have a 1. So in my model of biology, can you have a beta with only a v and not a sigma or an m? In my modeling, I venture to say, yes, you most certainly can. All right, so let's change. Let's leave sigma as a constant. Let's change, so we're just going to deal with 1 sigma, okay? And we're going to change m to be 3 and 4, and okay? And we're going to leave v as 1.
It says 1 times 2 is 2 plus 1 is 3. 1 times 3 is 3 plus 1 is 4. 1 times 4 is 4 plus 1 is 5. 1 times 100 is 100.
The model says that you can have 3 beta, 4 beta, 5 beta, or 101 beta, not recommended, with between 2 and 100 m with just 1 sigma. Let's change this then to a constant 1m with 1 sigma, and let's go to 100 and 1,000 v. So you have
sigma with 1m plus 2. This is going to be 1 plus 100 is 100, 1 plus 1,000.
So this model says that with 1m and 1 sigma and 2, 4, 100, or 1,000 v's, you can have 2, 5, 100, or 1,000 betas. The reason I eliminated this model to be a nonlinear model, so it's basically a curve that's not a chucking line. It looks like this, or it looks like this. You know, it might be a line right here where the tangent is, but we're going to do beta equals to pi of sigma equals, and let's say we have m sigma squared plus v. This will be a non-linear model, and the reason I decided it could not be a non-linear model is because I don't think beta can happen in a function pi of a non-linear sigma. I prefer to think that you can only have a beta with a linear sigma. So there it is, y'all. This is the kind of shit I come up with when I'm chucked up on math, man. I'm just geeking for that shit every day. Math has really been a lifesaver. I can't thank you enough for it. Remember to like and subscribe. Trying to make math fun. Mathjunkie.org is the website.